Okay, so I'm Amanda Lauter, and I'm going to talk about F-sharp concurrency. And you guys are probably all wondering, what the heck is this non-Microsoft person doing talking about F-sharp, which is our language, give it back? Well, I'm coming from a kind of an interesting perspective. I'm a consultant at the Sophic group, and they're probably one of the coolest companies that I have ever heard of, because they let me do kind of whatever I want, which is good because I can look at all the languages I want and decide what I'm going to recommend to clients and what I'm going to use. F-sharp has recently caught my attention. A lot of the concurrency stuff and just the ease of the syntax is really cool. And that doesn't mean that I haven't looked at Scala and Clojure and Mozart and all the other languages out there that are doing or trying to do lots of the same things. So that actually says a lot for F-sharp and the F-sharp team and what Microsoft has done. So yesterday I was talking to some people and I overheard some comments like, today's applications don't need to be parallel. The bottleneck isn't the CPU, so why bother planning for that? Most applications that we have can't even be made parallel. If you think about the way we've designed most apps, they can't even be made to use any of the features of F-sharp. So what are we doing? So are we wasting our time with all the HPC/functional talk? No. We've designed applications and tools, applications based on the tools that we've had. With the object-oriented languages, we've built kind of crappy apps that can't do the things that we need them to do. They can't use the CPUs because we've built them that way. It's not because they can't, the problem can't be solved in a way that we can use all of our tools. We're just solving problems for tools that we have. So basically, my thought is if you're still thinking like this, if you're still thinking that the CPU isn't the bottleneck, we don't need this, blah, 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 you're going to be obsolete. You're going to go away and not have a job very soon because people like me are going into our clients and redesigning their apps to use all of their cores. So let's talk for a second about how I've done that for one of my clients. I'm doing a case study with Microsoft right now. So most of you guys in here work for Microsoft, and you're paying me to go into Grange and tell them how to actually use your technology. So basically I went in and they said, well, we have this problem. We have this big calculation, which is made of all of these smaller calculations, and they all have to be done, and they can't be done in parallel. There's all these calculations being done, but it all has to go synchronously because the driver factor has to be done before the insurance score factor, which has to be done before the tier factor, et cetera, et cetera. So I looked at their implementation of C#, which they did a very good command pattern. They had a list of policies, and is everybody kind of familiar with the insurance domain, auto insurance? Good. So you have a list of policies that's coming into our engine, and each policy has different factors, which are calculations that have to be calculated. And each factor has to calculate for every coverage, every type of coverage like bodily injury and collision and all of those. And you get different rates for each coverage on each policy. Within each coverage, we have vehicles, and for every vehicle, we have drivers. So why can't this be made faster? Even though everything has to be done in sequence, we still have the equal signs along the bottom. They're not they're not down the right side. To me, looking at that, that was pretty simple to say, well, this can be made parallel because each of your coverages is not dependent on your others. So regardless of the way that you've designed it in the past for your object-oriented programming to be as fast as possible, you're not doing it the best way for the F# to do it. So my new design wasn't a very big design. It was just, we'll spawn processes for the policies and we'll do the coverages in an asynchronous workflow. And that actually extends to the fact that we can do the vehicles and the drivers in async workflows as well. So the code looks like this. We want to write policies that are coming in from their C# application. And we want to be able to say that we're going to pattern match over a sequence, which right now you actually, the lists in F# and the lists in C#, as most of you know, they're different. So we just change it over to an F# list. and we do some pattern matching to say we want to calculate the coverage for every policy in our policy list. Nothing too exciting there. So we spawn each of those off asynchronously. I don't care, when they return. It's not of any importance to me when they go out. If they come back, they'll handle themselves. Theirs will handle themselves. I don't want to have to know when they come back. I'm not going to do anything with the result right now. So then I want to be able to calculate the coverages. And again, I'm just doing simple pattern matching. I'm going to update the policy. This is where it's actually going to go off, do some stuff, and write to a database. So we have to get the results to write to the database. You'll notice, has everybody seen F# code before? Is everybody familiar with asynchronous workflows? At least a little bit? Okay. Well, you'll notice the async keyword here, or the async word where we're running. I should probably back up and explain them. You guys can't let me get away with just saying something and not knowing what the hell I'm talking about. Okay, so notice the async block here. We just write async with some curly brackets, and then we do some stuff inside the curly brackets. And then when we say async.spawn, this is basically just using the threading pool. And when I spawn it, it's basically saying, don't wait for the result. Don't go do your thing, and I don't care what happens afterwards. So here I'm gonna run a function, async.run get rates, which is the important part on the second line there. And what get rates is doing is it's actually creating a asynchronous workflow. If you see async.parallel and then it's using the square bracket, that's saying we're going to create an array of functions that can all execute at the same time. This is where a lot of the value of the F# concurrency is in asynchronous workflows. So we're using the policy vehicle. So again, this is a C# object, and we're going to just use for every vehicle on that policy, I need to create a function and add it to this array. Okay, so at that point, I want to go and find my result. I want to query the rate from the most basic factors. So basic policy factor is a function that if we dive into it, we're using a lazy block, and we're saying that we want to force all of these other lazy functions and then reduce them by multiplying them. And we'll come back to that. But first we want to dive into the average driver factor. And you'll notice that we're doing a lot of digging in. It's kind of going from the top of the tree and just getting deeper and deeper and deeper. So the average driver factor, this is basically we're going to go and we're going to find the driver factor for every driver. And we're going to add them all up and just get the average. Fairly simple, fairly straightforward. And you'll notice in red that I tried to give a little bit of detail of what this is actually returning. This is a unit type going into a lazy decimal. So what's the driver factor? The driver factor is an array of a list of functions that we want to be able to map force. I just created a little helper function that will force any lazy function to evaluate. So I map that to everything in my list. It returns a decimal list. I reduce that by saying take every item in my list and multiply it times the next. Go ahead.
Now,
2 minutes, sorry.
I'm not asking you a question.
Sorry. And then I'll return a decimal. So then for D in drivers, we're just going back up the tree now. For D in drivers, do that for everybody, add them together, and then divide by the number. So walking back out the tree, we return our result. We return to get rates, back out to the calculate coverages, and this is where we came and we spawned each process. So each one will happen asynchronously. So we took it from going about 450 functions synchronously per policy to 9 different threads or 9 different processes kicking off each one of these coverages for each policy. So that was our design, and that's what our results were. Go ahead.
You made some of this stuff lazy towards the lead. I couldn't understand why you were doing it.
Because it was in a file with a lot of other functions, and if it would evaluate every function from top to bottom, it was taking a lot more time. Some of the functions didn't need to be executed, so it never had to determine the value. So I made it all lazy so that I could force it when I needed it. Some policies need some factors and some don't. Go ahead.
So how does F# asynchronous workflows handle exceptions? Say like 15 or 30 things in the list through. What happens with that?
The way I implemented it is if it's whatever function is being called is in its own try catch, so it has its own exception, and that would write it somewhere or do something with it. So you handle it within the function that's being spawned, kind of just like with if you're kicking off several threads and you want to be able to handle an exception there.
But does it bubble up to your results? I mean, at some level you have to say what the heck happened.
Yeah, actually it will bubble up if I'm trying to care. There's a point in here where I actually say that I wanted to have all of my results added together. See if I can find it. Because the first time I didn't care. The second time I actually do care. See how I say let bang results equal? Well, that's saying let all of that. So eventually I end up reducing that down and adding them all together. So yeah, it will bubble up if there's an error. It'll tell me at the deepest level, if I want to pass it up, it'll tell me that won't evaluate if there's an error. Go ahead.
Do asynchronous workflows have a similar mechanism to like parallel extensions where if one sub-item actually in the parallel execution fails, anything else that isn't scheduled yet to run will actually cancel so it doesn't run?
I'm actually not sure about that.
So in a workflow, yes. If you use parallel, then no, right? You're spawning all that work in parallel, cancel it. But if you have a workflow that has dependent pieces, then they'll stop executing at the point where the exception was thrown. That'll get bubbled back up onto whoever started the async workflow running.
Right.
So it was in the sequential part, yes.
What I was talking about is like in a parallel.4 or parallel.4 each, if you actually spawn off 16 different things in parallel, and you're only on a quad-core box, and it's really only executing the first 4.
I think they'll all go
If
up.
the fourth one fails, then the other 8 actually won't execute at all, and it'll bubble up the exception.
Which iterations execute is up to the implementation. It may or may not be the first 4.
Yeah, absolutely. Yeah.
Any other questions? I've never done a 15-minute talk before. Go ahead.
Look at those numbers. There was F#1 and F#2.
Yeah. At first, I thought that the only place, and the company actually said that the only place we're going to find value in this workflow thing is if we just do the policies all parallel. And that's when I found that we could do each coverage in parallel. And so I did the results for what they were thinking would be best, and then going even deeper and parallelizing more. So we've found ridiculously good results. I mean, it went from a 120-second process down to like 2 seconds, so it was really quite valuable. Go ahead.
So presumably your client has to maintain this after you're done.
Yeah.
What do they think about the code? Do they think it's maintainable, that they can understand what's going on, read about their program?
So I had to ask the team that because that was part of our presentation in the end, and they said, yeah, we feel like we could definitely maintain this. We could make small updates if we need to, but if we had to come up with a design ourselves, you were only here for a couple of weeks. I don't know that we could come up with a design ourselves. So my next step is I'm going to spend 8 weeks training them on how to come up with these ideas and see if they can't do it themselves as well. So look for the report on that too. That should be pretty good.